Hello, and welcome to the tutorial on U substitution. Now, U substitution is how we take the antiderivative when we involve chain rule. Now, let's kind of review the derivative with chain rule. Chain rule says if we have f of g of x, then the derivative becomes f prime of g of x times the derivative of g of x. In other words, the derivative of the outside times the derivative of the inside. So very easy to do. Now, U substitution basically just goes in the we're going to start with the derivative, and we're going to take the antiderivative of this. So if I write out my derivative in here, into my integrand, how U substitution works is very simple. Don't forget your dx, that's telling me that this is a derivative, it's a differential. How U substitution works is very simple. We're going to let, whoops, my parenthesis here. We're going to let u be the inside function. That's how chain rule works. Remember, times the derivative of the inside. So going backwards, we're going to look at the inside. So we let u equal g of x. Now, if I let u be g of x, I'm going to get this, f prime of u times g prime of x. Now notice I haven't replaced my dx yet. We're going to do that in just a minute. But notice, I have u and I have x. Now, the whole goal of U substitution is to completely erase all of your x's, to eliminate them. You either want to substitute them, or you're gonna cancel them out. Now, notice we substituted g of x for u. Now, how can I get rid of this g prime of x? Well, to do that, we look at the differential, g prime of x dx. The derivative of g of x. So I'll go over here. Well, if I take the derivative of g of x, I get g prime of x. But I also got to take the derivative of the other side. This becomes du dx. So I get du equals g prime of x dx. Now, if you notice, look up, there's our differential again. There's our tangent line. But I can use this now to solve for dx. I get du over g prime of x. And now I can substitute that into my equation here. So instead of dx, I get now du over g prime of x. And if you notice, g prime of x cancel each other out. And what I'm left with is f prime of u du. Now, before we go any further, let's kind of review something. If you're taking the antiderivative of a derivative, they're inverses. These are inverses of each other. In other words, they cancel each other out. So if I take the antiderivative of my derivative, I'm just going to get my function back, f of x, plus a little something extra for my troubles. So I take the antiderivative here, and I'm going to get f of u. Yes, mathematicians have a wonderful sense of humor, plus c1. And now I'm going to put my u back in. Remember what u was? G of x. So I get f of g of x plus c1. So if you notice, when I took the derivative, I got my chain rule. When I took the antiderivative of my chain rule, I get my function back. Right there, plus the c1, our constant. So remember, the constant says, hey, because I'm taking a derivative, there might have been something here like a plus 1 or plus 5. That derivative became 0 when I took it. So let's take a look at some examples here. And this is very easy to do. So let's integrate the following. Let's say here we have x squared minus 9 cubed times 2x dx. Now, 9 times out of 10, whoa, focus, what happened there? There we go. 9 times out of 10, when we use U substitution, U is going to be the inside part. It's inside of something. Now, I could expand this, but U substitution is going to be a little bit easier than multiplying this by 3 times by itself and then multiplying by 2x. So I'm going to let U equal this x squared minus 9. Du then becomes 2x dx. We know that just from like up here what we did, right? We just going to multiply by dx to get my differential. And by using the differential, we can take du over 2x. And now I can rewrite this entire problem. This becomes u cubed times 2x, and this dx becomes du over 2x. Now, remember, you don't want to have u and x in the same problem. That becomes a problem for us. But luckily, what happens when I do u substitution correctly, those variables cancel, and what we're left with is just the antiderivative of u cubed du. And I know this. This becomes u to the fourth over 4 plus c1. Oops, that's an ugly looking u. Sorry about that. There we go. And at the very last step, put your u back in. X squared minus 9 over 4 to the fourth plus c1. And there's your answer. And we can do this with all sorts of problems. Let's take a look at a trig problem right here. Let's take a look at a trig problem. What if I did the antiderivative of the sine of, let's say, 2x dx? Well, same idea. This is a composite function. That's basically how we know we can use u substitution. So there's my 2x. There's my inside. U is 2x. Du is 2 dx. There's my differential. I get dx equals du over 2. And I plug it back in. Now what you're going to notice on this one, we're going to get the sine of u du over 2. The 2 doesn't cancel with anything. So, but it's okay, there's no variable there. If I look, there's only one variable, just u. But the 2 I can bring out to the front. I get 1/2 the sine of u du. And this becomes 1/2. What function's derivative is sine? Very good. Negative cosine of u plus c1. Now, notice this. It's 1/2 times all of that. So I'm going to distribute my 1/2 inside. And I get this. Negative 1/2 cosine of u plus, now when I take c1 multiplied by 1/2, I could write it as 1/2 c1. But that's just another constant. So we just normally write that as c2. And I'm almost done. Got to replace my u. Negative 1/2 cosine of x squared minus 9 plus c2. And there you have our original function. We can do this with even more complicated ones. Let's take a look at a really hard trig problem right now. Let's try the following. The antiderivative of, let's do this one, the square root of the secant of x. Oops, I'm sorry. Let me start that one over here. The square root of the tangent of x times the secant squared of x dx. Sorry, copy error. Now I'm going to rewrite this one. It's a little bit harder. Now I can do a lot of trig stuff with this one, but keep it simple. If I rewrite this, I get the tangent of x to the 1/2 times the secant squared of x dx. And I look for my inside. There it is. There's u. So u is going to be the tangent of x. Du becomes secant squared of x dx. Again, there's my differential. So we get dx equals du over secant squared of x. Now what's cool about this is, what you're really looking for, I'm looking for a function whose derivative is in the equation, is in the function up here. So tangent's derivative is secant squared. So that's going to be my u. By picking tangent, what's going to happen when I plug it back in? The secant should cancel. And they will, which you'll see. We get u to the 1/2 secant squared of x du over secant squared of x. Cancel, cancel. And we get u to the 1/2 du, or u to the 3/2 times 2/3 plus c1, or 2/3 tangent of x to the 3/2 plus c1. And there we have it. Alright, I'm going to take a look at one more, okay, and then on another video I'll show you some other problem if you want to take a look at a couple more here. Okay, so one more on this video here. So let's take a look at, what if I have something like sine of x times the cosine of x? Now, in every one of the problems that we have, u was inside. But in this case, there's really no inside function. So I can't take this antiderivative directly. I have to do something with it. Now, some of you guys may recognize I can write this as 1/2 sine of 2x. Not many people do. But remember what I told you up here. When you're picking your u, all you have to do is look. Is one function the derivative of the other? Yeah, cosine is the derivative of sine. I could do it the other way around. Sine is also the derivative of cosine. But I'm going to keep it simple. U is the sine of x, because its derivative is the cosine of x dx. So this is like a special case right here, when u is not inside, and when it's not a composite function. So I'm going to get dx equals du over the cosine of x. And I plug it in. And we get u times the cosine of x du over the cosine of x. And what cancels? The x's. The x's don't cancel, you messed up. Go back to the drawing board. U du, and I get u squared over 2 plus c1, which becomes the sine of x squared over 2 plus c1. Now, had you let u equal, if you let u equal the cosine of x, you would get this answer. Negative cosine of x squared over 2 plus c1. Different answer, but it would be correct as well. So take a look here, try these again, watch the video again if you can, okay, and I'll see you guys later. Bye.